Hi guys, in this episode of Chew the Fat, I've gone for a slightly different mode. This episode is more of a podcast or a vodcast with special guest Kaya Genc, who has done a lot of research in the area of low carb living. It's a long episode chock full of info, so put your earphones in and listen to it while you work or work out. Enjoy.
Are you cool to give me a quick bio of about yourself and how you got into this sort of space and stuff?
Sure. So my name's Kaya, 23 years old, studying psychological science and business at university at QUT. So my interest in nutritional science happened about 2-3 years ago. I was interested in bettering my physique and I guess, beating the body dysmorphia that I used to have back in the day. So I wanted to understand how to recomposition my body and what foods I needed to eat in order to get the right macronutrients. And here I am now.
Yeah, cool. I noticed on your Instagram bio, you're an athlete with Chem. What's the Chem?
Chemix. Yeah, I'm affiliated with Chemix Lifestyle. Just because the guy who makes the products, Gorilla Chemist, he actually makes some pretty well-dosed ingredients. He uses some really well-dosed ingredients in his products. So I promote his stuff because it's quite good and I guess effective compared to all the other natural supplements out there. So yeah.
And in terms of your own athletic stuff, what do you do? Do you train in any certain sports or compete in any fitness competitions or anything?
So I used to play football, soccer, like quite high-ish level when I was younger. Now I've transitioned into more resistance training. So, beating my psychological and physical barriers sort of thing and improving my physique and becoming better as an overall person, I guess. So yeah, resistance training is my main sport, but I also played tennis as well when I was younger. It's quite into that as well, but it's been more resistance training lately than anything.
Yeah, cool. Sounds good, mate. Mate, so I think you sort of answered the question before, but how you first got into the low carb eating space. You said you started looking at body composition and how you can improve your body composition. So explain to me in a bit more detail how you got into low carb and long term you're sort of down that carnivore sort of path now.
Sure. So I guess before I started understanding the scientific aspect to nutritional science, I guess I used to watch channels like Dr. Eric Berg and Thomas DeLauer, people that, I guess because I didn't have the knowledge yet of nutrition, I used to sort of look at them and be like, okay, I see what they're talking about. And they make some, points that make sense. So I guess ketogenic dieting was the second type of dietary pattern I tried. The first one I tried was intermittent fasting at first. And I was eating carbohydrates in my diet, so I didn't really notice much of an effect. But as soon as I went to ketogenic dieting, and that was 2018 in the middle of the year, I noticed huge improvements in not only my physique, but also my cognitive performance and just every health aspect, to be honest with you. I felt better. So it led me to, want to understand more about this phenomena. And this has led me to where I am now. So.
Yeah, awesome. So you talked about some of the health benefits. One of them being cognitive performance.
Absolutely.
I'm assuming you lost a bit of fat. What else? What other sort of health benefits did you notice?
My skin in particular was looking much better, inflammation in particular. So I noticed that with ketogenic dieting and eliminating the carbohydrates out of the diet, water retention also decreases because carbohydrates are osmolytic. So as I cut the carbohydrates down, I was getting leaner and looking, because there's not as much glycogen stores because of the lack of carbohydrate, you do tend to look a bit flatter, especially as a natural. There's the limitations to ketogenic dieting as well in the natural sense, but in terms of health benefits, though, my skin, my mental clarity, and just even my athletic performance, especially in longer distance events like football, for example, was enhanced for sure. So I definitely like utilizing a ketogenic diet, especially for cutting in particular.
Yeah. No, it's really funny you say that because I guess there's a lot of research has sort of identified carbohydrates as being so important for athletic
Yes, of
development,
course.
especially for long, what do you call it, like games like soccer and rugby and stuff that are played over a long period
Yep.
of time, that do
Yep. Yep.
require, you know, a bit of anaerobic as well as the aerobic system, and a lot of the previous, I guess, research has sort of suggested that like glucose is really important for anaerobic system. But it's funny you say that your performance improved, because I've found, for me personally, my anaerobic performance has improved tenfold on a ketogenic diet. Whereas all the evidence and everything I read says that shouldn't be the case. But I don't know if
Yeah.
it's something in my head mentally sort of making me work harder because I'm on this diet, or whatever it is. It is improving, I guess, my performance in the gym. I did some maximal aerobic speed training the other day, and it was the first time in a long time I got through a whole session without any like muscle strain. So usually I get really bad calf strain. I got through a whole session without even feeling a thing. So that was really good, and also really interesting that you talked about your skin. My
Yes.
skin at the moment is a bit blotchy, but I found I get a little bit of eczema, and I found while I've been on the ketogenic diet, my skin has completely cleared up. My rugby team on the weekend had its first win for the season, so I did break my my ketogenic diet and had a couple of beers. I was sort of peer pressure forced on me, and they're saying, "Come on, mate, you got to have one." So I did have a couple, and I probably broke that sort of keto diet for the first time in well over a couple of months. And the first thing I noticed is a little bit of red blotchiness on my face again the next day, and that sort of like more itchy sort of scalp and dry scalp. So the only thing I can contribute that to is having carbohydrates that day. So
Yes. Also, one mechanism that I'd like to go into as well, which I've learned this year in particular, is the glucose fatty acid cycle, or the Randall cycle. And the Randall cycle, what it shows is that fatty acid oxidation inhibits glucose oxidation. So essentially, when you mix the two macronutrients in the diet, this essentially causes damage to mitochondria, pro-inflammation, and if you do this in the long term, it leads to a chronic systemic inflammatory response, which can lead to atherosclerosis and all these other chronic degenerative diseases down the line. So we realized that you need to include one of the macronutrients in the diet with protein, of course, in order to maintain cognitive and physiological function, right? So when you add them all up, I've realized that fat wins every single time over carbohydrate, and especially in terms of endocrine function, in general physiological function, well-being, psychological function, it's just better in general. With carbohydrates, I notice when I include higher amounts of them in my diet, which I haven't for quite a while, to be honest with you, I feel lethargic, I don't feel as motivated, and I feel like sometimes I can feel kind of bloated and uncomfortable, and I notice the water retention as well, carbs being osmolytic. So I definitely notice a difference when I include higher carbohydrate intakes in the diet. But with, just fat and protein, I feel so much better. It's just a whole different ball game, especially carnivore in particular. When I included no carbohydrates in my diet, it was the best I'd ever felt. And especially as a psychologist who wants to go into nutritional neuroscience or neuroscience, I love understanding the enteric nervous system, so the gastrointestinal tract, and the central nervous system, and how they work in unison with one another. So when I realized that I was feeling amazing on just meat, something clicked in me. I realized, okay, so if I'm functioning neurologically really well, or psychologically really well, and also my gut feels the best it's ever felt, why is this phenomena happening? So this led me to research more into this topic and understand things like ketones, the physiology, the biochemistry, and various other sciences that go along with this. Especially with areas, this will answer a lot of your questions as well, especially with areas like nutritional science and past data in particular. We notice that these studies are, let's be honest, very poorly tenured. They don't have really good external validity. They're poorly, moderately powered, and they're all associative, or they all don't control for many variables, variables that can't be equated for, like external environmental variables or even internal environmental variables like biological or genetic variability, for example. So these nutritional science and epidemiological studies in the first place are quite limited in giving us any causal inference.
Yeah.
So that's why I had to move on to areas beyond nutritional science and epidemiology, like biochemistry and physiology and anthropology, for example, and neuroscience, you know, the area I study, and apply it practically to myself to see, you know, what works and also what the research actually says in terms of mechanistic data and et cetera, et cetera. And that's led me to believing that, you know, the human diet is meant to be a carnivorous one for various reasons. And we can go further into this as we progress through this interview. So,
no, that sounds good. And I guess that was going to be my next question was, you talked about initially starting on a ketogenic sort of diet or pathway, and you moved down to a more of a carnivore approach, or like a high protein, really meat sort of, I guess, saturated diet. So what's the reason from going from, I guess, keto, which is probably higher fat and moderate protein, if I'm correct, compared to that carnivore, which is probably a higher amount of protein, still a moderate amount of fats, I guess. What's the reasoning there?
So two reasons. One, a lot of the anecdotal evidence. So I was noticing on places like YouTube and a lot of other social media platforms that all these people were reversing their autoimmune conditions and their mental health disorders and all these various other psychological and physiological disorders. So I was thinking, why is this occurring? And what is the reason for this? What is the mechanisms behind this? So I guess also, as a friend once told me, he tried it and said it was the best he'd ever felt in his life. I decided, all right, I'm going to cut the vegetables out and see how I feel for 1 month and test how this goes. And well, here we are now. Second reason as well is being, interested in neuroscience. I love understanding the neuroanatomical structures of the brain and what the brain is made out of. And when we look at how our brain is structured in the first place, we realize that 60% of it is made of fat and 40% of it is made of proteins. When we look at, of that 60% fat portion in the brain, 50% of that is made of polyunsaturated fatty acids. So 25% of that is omega-3 fatty acids in DHA and omega-6 acids in omega-6 fatty acids in arachidonic acid. Then the other 25% of that 60% portion is omega-9 oleic acids, which are monounsaturates. And then the other 25% is saturates. So we think, how did our brain structure this way and why did it structure this way? And we look at our genetic evolution and also papers like the expensive tissue hypotheses by Leslie C. Aiello and Peter Wheeler. And then you realize, oh, okay, it explains why our brains have structured this way or formed this way over time. It's because of the animals. It's clearly not from the plant material, the saccharides, the carbohydrates. So that's the other reason as well. So I was thinking, if my brain is structured this way and my body is structured this way, especially my GI tract and my physiology in general, this is meant for, meat. It's meant for animals. It's not meant for plants in the first place. And even studying, the chemical warfare of plants and their defense mechanisms, it made me realize that, okay, maybe these things aren't meant to be in the diet in the first place, and maybe humans are more adapted to animal-based nutrition, or more ancestral nutrition. So yeah, that's what's led me to being here right now.
And I guess it sort of really sticks out, that sort of caveman sort of approach, in those periods when they didn't have pasta breads and cereals and stuff like that. I guess they weren't farming grains. It was just, hunter-gatherers.
Some of those vegetables in particular and fruits haven't been around some of them have only been around for 9,000 years or 10,000 years in existence when agriculture first started. So some of these haven't even been with us throughout our whole evolution. And then you look at the micronutrients that these plants are missing, and it's not just one like B12, it's vitamin A, it's D3, it's K2, it's collagen, it's taurine, carnosine, creatine, etc., etc. And then you realize these things are all needed for various physiological functions. A lot of these are essential amino acids, which serve purposes, especially on a psychological or neurochemical level, especially with your neurotransmitters. A lot of these require protein in order to become biosynthesized. So it seems as if, like I was saying before, the human is designed for the minerals and vitamins from animals in the first place. And again, this is why I always seem to come back to, okay, it seems that the human diet should require more of a fat, lipid, and protein based dietary pattern. That's what the human should be following in order for optimal health and in order for, for cognitive, physiological, and just general health in general, I guess.
Yeah. So what do you say to people? Like, one of the big things that people say to me at the moment is, how am I getting all my vitamins, such as, the things like vitamin C, which is common in fruit and vegetables and stuff. So that might be something that I'm, common in a lot of the food that I've given up at the moment. What do you say to people when they make that argument, come with that argument that, you need vitamin C, you get scurvy, you get all these other issues because you're not getting vitamins?
I've heard this one so many times, to be honest with you, and studying it so much now, I've now sort of memorized how this all works on a mechanistic scale. So essentially, there's a pathway in the body called GLUT4, or a glucose transporter pathway. And essentially, vitamin C, ascorbic acid, and glucose are very similar in chemical structure. I think it's 4 hydrogen ions difference. Vitamin C can replace glucose in preventing non-enzymatic glycation of proteins as well. So vitamin C does serve a purpose. However, what we realize is when a diet, say, is high in carbohydrate, the requirement for vitamin C goes up because glucose and vitamin C, being chemically similar to one another, both fight for that same receptor or that same pathway in the body. So the more glucose you have, the more vitamin C you need. Also, the more reactive oxygen species in the diet, which will come from plants, obviously, and this is due to deuterium. Deuterium interferes with something in the epithelial tissue of the gastrointestinal tract. They affect some enzymes called ATPase synthase, which is important for energy production in the mitochondria. And this can cause various gastrointestinal tract disturbances and also a lot of cellular physiological disturbances. With meat, for example, the fact that there's no carbohydrate or low amounts of deuterium in the diet means that the requirements for vitamin C and to fight off those reactive oxygen species, it becomes diminished. And if anything, antioxidants from the diet is not a good thing in the first place. The antioxidants that should be acquired from grounding or your own antioxidants, your own endogenous antioxidants, like, for example, superoxide dismutase, glutathione peroxidase, alpha lipoic acid, etc., etc., etc. So I guess maybe that gives you an idea about vitamin C, but also with vitamin C as well. Higher amounts of vitamin C means that vitamin C, ascorbic acid, is more prone to oxidizing into its oxidized form, dehydroascorbic acid, and that form can oxidize into oxalic acid or oxalate, which there's a lot of mechanistic and experimental research on, which is showing that it's damaging to mitochondria and also interrupts the redox homeostasis reaction in the body as well. So there's some interesting research on oxalates and why they shouldn't be in our diet, how they penetrate the blood-brain barrier, and how these things can cause various physiological problems. So yeah, I hope that gives you a bit of an idea about vitamin C.
Yeah. I've probably lost a little bit of the scientific jargon, but I
sorry about that. Yeah.
No, that's all good.
To simplify that down, though, sorry, if you want that bit simpler, basically, the more carbohydrate or the more reactive oxygen species in the diet, the more vitamin C that's required, or more glucose in the diet, the more vitamin C that's required. The less glucose in the diet, the less vitamin C that's required.
Yeah. So when you hear stories about the people who came across in the first fleet and the scurvy and stuff like that, they were probably eating large portions
of carbohydrate diets like bread,
grains and stuff. Yeah.
Absolutely.
But they weren't getting any of the other the fruit or anything that opposes some of the side effects that might occur. Would I be right in saying that?
Yes, correct. Yes.
Yeah. And am I correct in saying that that meat contains a lot of the vitamins and even to some extent vitamin C that we require, because it's so nutrient dense, especially some of the organ meats like liver and stuff. Would I be correct in saying those sorts of meats are very nutrient dense and have a lot of those, a lot of the things you already talked about, carnitine, creatine, all those sorts of things, but a lot of the other vitamins as well that we do require for health and yeah, cool. So I guess I'm quickly going to touch upon this one again. That we get a lot of nutritionists suggesting that carbs are vital as our brains run on glucose. So what do you say to this argument? I've had people come up to me and say you can't starve yourself from carbohydrates because our brain runs on glucose. And if you starve yourself from carbohydrates, your brain's not going to function. So yeah, I don't know. You've got to turn to this, dopey blob that doesn't know what you're doing. So I haven't noticed that at all. But I just thought, again, from the scientific side of things, you've got your head around all of this a lot better than I do. So you might be able to explain it with a bit more common sense than I can.
Sure. So a lot of people think that glucose is necessary in the diet because 20% of our brain uses glucose as energy, but our brain can also use ketones as energy as well, conversely. So that's also pretty cool as well. But you got to realize that glucose can be made via the fat in our diet, via the triglycerides. That can be converted into glucose itself. So via the process of gluconeogenesis, our body can make its own glucose. And would that be more effective than, say, obtaining glucose from an exogenous source? Well, personally, I do believe so, yes. When you look at the chemical structure of glucose in particular, you'll notice that it contains a polyhydroxyaldehyde unit to its molecular structure. Aldehydes in the literature have been shown to be mutagenic, carcinogenic, damaging to DNA, RNA. They're highly reactive oxygen species, just something that a human clearly doesn't want to deal with in the first place. They are quite neurotoxic and can be very physiologically detrimental to the body. So yeah, I would assume that, getting glucose via the fat in your diet would be the better way to obtain it, and also not to mess up the GLUT4 pathway, as I was speaking about before, because if you have an influx of too much glucose and vitamin C, this can, of course, lead to oxalate buildup, but also lead to insulin resistance and pro-inflammation. You've got to realize vitamin C is osmolytic as well. It holds on to water. So the more you have, the more water you will hold on to, and that can be inflammatory and problematic for some as well, especially if you are eating a high amount of carbohydrate and fat in your diet. So yeah.
And I'm just going back probably a little bit as well. There's you hear about all these papers, all these research papers, and I think one came out last year or the year before, and it was on the news and everything about how meat causes cancer. What do you think about this argument that eating red meat every day causes cancer and it's carcinogenic, and you're going to drop dead in a couple of years if you eat too much meat, sort of thing.
Mm-hmm. So the red meat paper, the one that establishes class 2 carcinogen, well, this was written by the World Health Organization. This contains 20 studies within this 2-page paper. It's literally only 2 pages long, which is alarming in itself. But also, when you look at the research that embodies that paper, you realize that this is all done on rats, and some of them on humans too. But do we see any cancer within these humans or these rats, even when these rats are injected with a carcinogen before they're fed the animal-based diet? No, we're not seeing any of this whatsoever. So is there some bias towards this research, or some funding behind this research, or an agenda? Very possibly. I mean, if you want to look into the Seventh-day Adventist Church and all that, sure, you can, and whatever else is behind the scenes. But yeah.
No, I just thought that, again, just something, it's something that people talk about a lot to me now that I'm sort of on this ketogenic diet. And as I said, because I've been probably training a lot more, initially I started off with very high fat content, pretty moderate carb, pretty moderate protein, and very low carbohydrate. But because I've been training quite heavily, because again I've felt so much more energetic, I've found that my protein macros have gone up, I'm eating I'm eating a lot of red meat on this diet at the moment. Again, I'm going for the sort of fattier cut. So Scotch Field's probably my meat of choice at the moment. But
Yum.
yeah, so I'm eating a lot of that, and yeah, everyone's saying to me, it's carcinogenic. You shouldn't be eating that much. The Heart Foundation says only eat red meat twice a week and all that sort of stuff. And I'm like, you know what? If I'm feeling good doing it, why should I stop? And initially when I did this, it was going to be like for 3 months and see how I felt and see if I got results. And at the moment, I'm getting results, so I'm looking at gut thinking, I'm going to start on this pathway, and again, as I said, probably stay on the increased protein and high fat. So just keep those carbs down as much as I can. So yeah, I'm actually enjoying it. I just next question I had was so when I talked about the our brains run on glucose, and a lot of the nutritionists say how important carbohydrates are for just general day-to-day living. The same could be said with athletic performance, and as I mentioned before, Louise Burke, who's a sports nutritionist, who's done a lot of research in this area, is one person who really advocates carbohydrates and how important they are for, I guess, athletic performance. Again, do you want to just quickly touch upon that and give me your thoughts and obviously again,
absolutely,
that scientific background?
Sure. So with bodybuilding in particular, if, for example, you go the enhanced route and you want to compete and you want to compete at a higher level, yes, carbohydrates are definitely going to be needed in the diet in order to build on more muscle, because muscle building is an inflammatory process, right? Especially if you're trying to pass your your physiological barriers, especially with the enhancements. So carbs would definitely be needed for spiking insulin in order for that glucose disposal agency effect, and also for the fullness as well, for the glycogen stores. So in that context, yes, carbohydrates would be needed for sure. However, as a natural, no, I wouldn't think that carbohydrates are needed at all, especially the fact that you can make your own glucose, like I said before, via gluconeogenesis, and can use that very well for cardiovascular and even resistance training as well. So I honestly don't see the problem with eating no carbohydrates and doing training, because in my own experience, I noticed that I'm way more energetic personally when I eat just meat. I feel more driven, more motivated, and seems like everything on a neurochemical or psychological level, it seems like everything is homeostatic or in balance. And I always have this need to just keep pushing harder and beating my goals, especially when it comes to eating a high fat diet. I feel more motivated, like I said before. So yeah, there's that aspect to it. But also I would believe that meat is absolutely needed in a bodybuilding regimen for sure as well. Because again, you're getting most of your macronutrients from the meat as well, especially B12, which is important for the methylation cycle in the body. And of course, these micronutrients would also be very, very crucial to muscle building as well.
Yeah.
So it depends on the context. So if you are an enhanced athlete and you're someone who's competing, I think carbs would absolutely be necessary. But if you're someone who's natural, like look at Dr. Sean Baker or Dr. Paul Saladino, for example, they perform quite well, especially at their age. And, they still lift pretty decent weight. They still seem functional and mobile. So I don't see the problem with no carbohydrates in an exercise regime.
Yeah, and I'm the same. I'm, all natural, and as I said, my lifting has improved, I think. I was really stagnating previously on I had quite a high carbohydrate intake, very high refined carbohydrates. And I found that I was just very sort of sluggish, and when I trained, it'd be, I'd be just there going through the motions. Whereas now, and again, I don't know if it's like a psychological thing, a bit of a placebo. I'm not sure. If I can't put my hand in it and say, this for sure. But since I've been, going ketogenic, or at least high protein, high fats, low carbs, my training's gone through the roof, which is completely opposite to what I expected. I thought I'd be sluggish in the gym. I thought I'd lose weight, but yeah, it's actually been the opposite. So, which is really good. So yeah, I'm loving it. I might skip on to the next question. So,
Sure.
well, the next question was there any evidence or scientific research to support a lot of your claims, or is it personal opinion? I think you've pretty much covered that. You've been writing some like research and evidence throughout the chat.
In the nutritional science area, in the epidemiology area, not really. I don't think there's any carnivore diet evidence out there in that field.
Yeah.
There is a little bit in the nutritional science field. Nothing causal, of course, because I mean, is anything causal in nutritional science? It's all pretty much associative, or again, poorly tenured, poorly or moderately powered, and again, can't inform us on causal inference. So the nutritional sciences studies that do support meat intake, even then you can't rely on those because they're all associative, and a lot of them are based off questionnaire data or observational data. So many various limitations. However, in other sciences like the anthropology, for example, yes, there is some you could say causal evidence of for example, our ancestors eating a pretty carnivorous diet, and this can explain a lot about our brain, how our brains have evolved that way, our energy intensive brains. And this would be because of the supplementation, the addition of fish in the diet in particular, and that would explain the need for DHA, EPA, and DPA. So the N15 isotope analyses in particular are some great papers to read, and definitely, changed my mind a lot about human evolution and dietary requirements in the first place. So that was a nice paper to read. Just various other anthropological papers as well. Like I said, the expensive tissue hypotheses, the weaning behavior by Suni et al. And one of my favorite ones, Pond and Matix 1985. So Pond and Matix, these two biologists, they dissected 202 different mammals, and they looked at the adipocytes of these mammals, so the fat cells. And what they notice is the carnivorous animals tend to have smaller fat cells, but more of them. And the herbivorous animals have much larger fat cells, but there's less of them. About 4.7 times the size difference from what the paper says. And when we look at the human exhibits that of a carnivore. It exhibits smaller adipocytes and larger amounts of them. And Pond and Matix concluded in their paper that the diet for the human should be, I guess, a lipid and protein-based metabolism. Yeah. So that was another paper that sort of gave me an idea of this, I guess, this phenomena. And from there on, I guess we'll see what research comes to fruition from here in terms of ketogenic dieting and carnivore. Another thing as well is ketones is another area of research that's sort of emerging as well. With ketones, Beta-Hydroxybutyrate in particular, one of the ketone bodies that's produced during a ketogenic diet or a ketogenic style of eating. It's been shown to be neuroprotective and also protective to the nerves and the brain. So that's also some very interesting data as well. It's very interesting to see what ketones could be doing on a systemic level and how they could be actually alleviating a lot of inhibitions within the body. So keen to see what emerges from there on.
There tends to be, I think, probably more strength in the research on the neurological effects of ketones and how they can improve, a lot of brain disorders and I guess neurological issues.
Epilepsy, ADHD potentially. The ADHD mechanism relates to glutamate and conversion into GABA or gamma-aminobutyric acid, which is a neurotransmitter important for anti-anxiolytic effects. It's inhibitory, so it's one that makes you calmer, I guess. And ketones allow for that process or that synthesis to happen within the body. And a lot of some of the research is showing that these the glutamate with carbohydrates will convert into aspartate, which can be neurotoxic, especially at higher doses. So there was that as well that I read, and it kind of skewed my opinion towards, okay, balance might not be the way to go for the human. It might actually be what the Randall cycle is telling us, and that is, the mixture of both macronutrients in the diet is not needed whatsoever, and one is definitely preferred. And then we look at the mechanism of the Randall cycle. So I'll elaborate more on this. When we look at some of the papers on the Randall cycle, we'll see that, as I said, fatty acid oxidation inhibits glucose oxidation. So when you mix the two macronutrients, you'll realize that fatty acids are always preferred over glucose. The glucose that's in the diet as well with it, only 10 to 40% of that glucose will be converted into ATP, or adenosine triphosphate, for energy production. But 60 to 90% of those fatty acids that are eaten will be utilized into ATP. So clearly the body is using fatty acids more. It's utilizing those fatty acids more. And when you think about it, yes, we require essential fatty acids, but there's no essential carbohydrates, is there?
No, it's not. So what you're basically telling me that when we talk about a balanced diet, that's probably the worst thing possible here.
Oh, absolutely. And it's also why some of the vegan studies have been quite successful. Like, for example, the Esselstyn study, which is kind of successful, if you want to call that successful, but eliminating the fat from these patients' diets, the ones who had heart disease and the atherosclerosis, and it regressed. This would also be because of the Randall cycle, because of the fact that they're eliminating the fat from their diet, but they're having high carb and protein. So, okay, there's no substrate competition. But will there be nutrient deficiencies from that? Absolutely, of course, because some of the vitamins we eat are fat soluble. So you'll need to get them from fat, in particular D3, A, and K2 and E. So, but you can get E from plants.
Yeah, cool.
Same with animals too.
Yeah. I think only the one last question was, in the keto and the carnivore space, there's a lot of talk about having higher sodium content in the diet, whereas this sort of contradicts what we're taught again in the Australian Guidelines to Healthy Eating. They talk about having very moderate to low sodium content, but everything I hear about, everything I read about in the keto space, the carnivore space, is high sodium. Can you shed any light on that one? Why, I guess, having salts and stuff is important when you're eating this way?
So within our physiology, we have a lot of sodium ions within our body, which serve various physiological purposes, especially in the brain. It serves a purpose for something called an action potential. So sodium is important. It's a very critical electrolyte. And you'll notice that when you're lethargic, or when you've completed exercise in particular, your body's always losing electrolytes. So you'll feel exhausted, lethargic, and you're craving water. You're thirsty all the time. And your body actually requires sodium in order to, have that uptake of energy, but also to prevent dehydration and also to function properly as well. Sodium is very critical for physiological and cognitive function. So I definitely feel like more salt should be included in the diet. The RDIs on salt, which I think was 2,300 milligrams, I think that's a bit low. Because sodium is a very critical aspect. And I think with salts as well, we should be mindful of what salts we pick as well. You could just go to the supermarket and buy a general iodized sea salt, or you could buy a Himalayan pink salt, which has way more minerals. So salt choice matters too, of course, but also sodium does matter and definitely is needed for sure. The only time I would cut sodium, I guess, would be, say, if you're cutting for a bodybuilding show and you're trying to look, I guess, the leanest you're trying to look. Okay. But yeah, other than that, that would lead to a lot of detriment as well, especially because.
So sodium, it's not. Now, one of the I guess things I believe was sodium acts like a diuretic and it actually dehydrates us. So you're saying that the sodium is going to help us retain water and.
Yes, correct.
Okay.
The more sodium, the more water that will be retained. But I think that also depends on diet as well, because sodium's not calorically dense. There's no calories in sodium, so it's not going to store any fat. But I guess it matters what you eat with the sodium. Say if you were to eat a high carb and also, mix some fats in the diet, you probably would hold on to more inflammation and look more water retentive. So
okay. And I guess I'll throw this one as well, is the cholesterol argument. A lot of, so today I was speaking to someone and they said to me, doesn't your cholesterol go through the roof if you're having really high fat content? What's your, I guess, what's your thoughts around that high cholesterol argument when you're on either a ketogenic or a carnivore type diet?
I don't have a problem with cholesterol at all, to be honest with you. The more I studied into physiology and biochemistry and I guess those other sciences relating to health, we realized that cholesterol, especially LDL, like low density lipoprotein cholesterol, serves various physiological functions, like mediating insulin resistance, hormones. It's a precursor for vitamin D3. And we also look at our brain structures, and you've got to realize 80% of the cholesterol we get is in our body. So in our the myelin sheaths of our brain, 50% of that is made of cholesterol. So the myelin sheath is important for action potentials or speed of propagation to happen across. So, you know, it's needed. And also the cell membranes are protected by two lipid bilayers, and one of those lipid bilayers is cholesterol. So LDL and HDL and the other lipoproteins, you've got to realize these are the same molecule. Cholesterol comes as the same molecule, whether it's a smaller form or a bigger form. The problem is when cholesterol oxidizes, so converts into oxysterols. So that causes inflammation within the endothelial lining, and you know, plaques can form over time from that. And usually this happens because of the glycosylation of proteins. So that happens via, you know, eating carbohydrate. So, and there's research on that as well, which is interesting. Another thing as well is when we actually expand on the literature on LDL cholesterol, we realize that we're not seeing a linear pattern here. We're seeing detrimental results with lower LDL levels, because some of the research is saying lower LDL is better for our health. It keeps your heart healthy. That couldn't be further from the truth. You want to damage your physiology, lower your cholesterol levels, because that stuff is actually very important for you. You need it. And without it, you would die. You would crumble. Like I said as well, when we look more into the research into LDL cholesterol, we notice that people who have lower LDL cholesterol levels have higher chance of mortality. They have higher chance of stroke, Parkinson's. So we see these problems with low LDL cholesterol levels as well. And we realize that, okay, I don't think we have something here that's establishing a causal inference. It's definitely not cholesterol that's causing the problem here. It's not cholesterol. It's, well, various other factors that cause these cholesterol particles or molecules to oxidize within the endothelial tissue. So yeah, that's my stance on it. I don't believe that cholesterol is a bad thing at all. And it does offend me when people ask me, oh, what about saturated fat and cholesterol?
Yeah.
No problem with that. Even heme iron in particular. When we actually read biochemical papers, we realize that heme iron is our most bioabsorbable form of iron. So why would we eliminate or negate that from our diet when it's vital? It gives us nutrients, gives us function, neurological function. Without iron, we become anemic and we become lethargic, weak, and all these other problems occur as well. So iron's definitely needed.
I'd imagine that iron is one of the most important things. I mean, it's abundant in our blood, so I'd imagine that would be one of the most important nutrients that we can.
Oh, absolutely. And for our neurotransmitters as well, in particular, like norepinephrine and epinephrine requires iron in order to come to fruition as well. So iron is a very important mineral, and cholesterol also is a very important lipoprotein. There's a reason that the ApoB100 gene has survived 3,800 million years of evolution. There's a reason for that. It's because it's needed. It serves a purpose in our body. Down-regulating it, not a good idea. Well, yeah, from what I understand in biochemistry and physiology. So, yeah.
Yeah, brilliant. All right, Kaya, that's all the questions that I had for you. I don't know if there's anything else that you wanted to discuss or expand upon that you think really important. I've enjoyed the chat, and again, like you're really knowledgeable on this, and you know I follow you on Instagram and read a lot of your posts and stuff, and you tend to always have a lot of good information, and you're feeding information back to me that helps me on this I guess ketogenic sort of carnivore journey that I'm on.
Happy to help as well. But
great.
Now, this is something that I'm very passionate about. This is something that I want to understand. I want to understand the observable phenomena within our objective reality. I want to be an empirical scientist when I'm older, and this is what I want to do as a career. So researching into this stuff, finding the answers to this stuff. I love doing it. It's a passion for me, and I want to be one of those people that provides information to people and doesn't provide misinformation or misrepresents data, because that can be problematic and can lead to a lot of false expectations or false results or poor results, mind you. So, yeah, factual information is very important, and I will plan to always be an empirical scientist for as long as I live.
But it's funny you talked about, you know, a lot of the studies are very associative, and I guess Sean Baker's raising money to run a study on carnivore diet.
Yes.
Could you ever see yourself involved in it'd be hard to get around the ethical things of how we could run a study, because, you know, a lot of the arguments would be you'd need twins with, you know, the identical sort of.
Yep. I agree with that. Makes sense.
To get a really good understanding of how one diet affects somebody compared to the other diet.
Absolutely.
I don't know what the answer is there, but you know, maybe one day you could.
No one does, to be honest with you. Again, that's why my hypothesis is that the human diet is carnivorous, and that's why some people have the hypothesis that plant-based diets are right for the human, and some have the hypothesis that we're omnivorous. And I'm fine to listen to all opinions. I'm fine to hear everyone's perspectives on the matter, but I can't stand the misinformation. There's a lot of misinformation that's spread out there, and that needs to be eradicated, because it leads to health problems. And let's face it, let's look at our obesity rates in particular. Ever since these dietary guidelines have been implemented from the 1970s, obesity rates have increased. And we look at what's at the top, or, you know, the bottom of the food chain, and they always tell us, eat your grains, because that's better for you. But the sad part about that is grains are probably one of the most toxic foods you could actually eat. And this is mainly because of things like gluten and also lectin in particular. Lectin has been shown in various studies to damage the gastrointestinal lining and lead to leaky gut syndrome and other gastrointestinal problems. And gluten as well is another one, an anti-nutrient in a plant that binds to a protein in the gastrointestinal tract called zonulin, and it damages the epithelial tissue and can also lead to leaky gut syndrome or gut intestinal permeability. And other anti-nutrients, like I mentioned before, oxalates too. Oxalates are a terrible compound from what I understand and from what the research actually tells us. So plants produce oxalates as a defense mechanism, because obviously plants aren't ambulatory, right? They can't run away from their attackers. So what do? They produce chemical warfare in order to protect themselves. Oxalate being one of their main chemicals. Oxalate has been shown to lead to calcium oxalate kidney stones, hyperoxaluria, can affect ADHD because it enters the blood-brain barrier, and can cause various other physiological disturbances. So oxalate is something that I don't personally promote in the diet, and I think people should be trying to avoid that at all costs if they're worried about their health and potentially not getting a kidney stone or a neurological problem. But this is the other part as well. These are not the only anti-nutrients that are in plants. There are so many different types of anti-nutrients that exist. Salicylates, phytoestrogens, exorphins, gliadins. I could go on. There's just tons of them. And there is research on a lot of these which show that they have detrimental effects to our physiology. Salicylates in particular, it's an ingredient used in aspirin. Salicylates is a compound found in plants, which has been shown to lead to toxicity in some people and impair their neurological function, can lead to cerebral damage, lethargy, and various other disturbances in the brain. So some of the data on the anti-nutrients in plants is actually quite frightening, to be honest with you. And it definitely leaves me wondering, why are people extrapolating and saying, oh, plant-based is the way to go, when clearly it can't be. It doesn't make sense, to be honest with you, especially in terms of the nutrients. It makes no sense whatsoever. Yeah.
So a few people have said to me, I'm doing this ketogenic style diet for 3 months, and people have said to me, after that, try going vegan for 3 months and see how you go. But what do you say to that? Stay away from.
I'm very glad. in my experience, I've never tried veganism. I'm so
Yeah,
glad that I've never cut meat out of my diet. For
yeah,
the past 2 years, I was eating just meat and vegetables and sometimes fruit because my original philosophy was that whatever's in nature, that's what we should be eating.
yeah,
But the more, like I said, the more I studied into this stuff, the more I realized, okay, plants actually do contain anti-nutrients, and these things, well, yeah, they may actually be problematic for humans, especially with some of the animals that are herbivorous in particular.
yeah,
These creatures have enzymes like cellulase in order to digest that cellulose from plants, or phytase in order to digest the phytic acid, for example, from plants. So they
yeah,
have enzymes to digest these things. We as humans don't. Another thing is the cecum of the human being. It's like 2.5 inches long. You could practically say it's non-existent or doesn't have a function. But the cow's one it's quite big, and that chamber is used to ferment that fiber or the grass that they eat into saturated fat. Whereas the human gastrointestinal tract doesn't need to do that in the first place. Doesn't need to convert those that fiber into short chain fatty acids and butyrate. We can get that butyrate via ketones, via beta-hydroxybutyrate, and I mean, which is actually stronger than butyrate itself. So yeah, when you add this all up and I guess understand the phenomena more, you'll realize that, okay, there's some real issues with what people are communicating in terms of the nutritional science and epidemiological data. And there's some various flaws that seriously need to be looked into. And we need to go deeper beyond, because that science is not giving us the full picture. We're not getting a full idea or full spectrum of what is right for the human being in terms of optimal nutrition.
yeah, yeah. Awesome, awesome, mate. You're full of information. I'm guessing you probably could sit here and speak for hours and hours, but I won't keep you all night. Just before we go, when it comes to, obviously you've done a lot of reading, a lot of research. When it comes to, I guess, experts in the field of the, ketogenic and carnivorous sort of diets, who are some of
Yep.
your like the who are some of the top people, or let's say 3 or 4 people that you'd suggest to listen to on YouTube or to read up on their
Sure,
research?
sure. So one channel that I actually appreciate so much is Bart Kay's channel.
Yeah,
Bart Kay is a physiologist from New Zealand, a cardiovascular pathophysiologist, I think. Yeah, his channel has actually given me so much insight onto this whole nutritional science field and made me see it more than I ever have. Understanding how the statistics even work within it, and how to read them properly and how to understand the flaws within those statistics and what they infer. It really has it's changed my life, to be honest with you, and it's made me able to read studies better than I ever have been able to, and it's made me able to read the numbers of the thing as well, and get an idea of whether this is causal or not.
yeah,
So Bart K is definitely one channel that I appreciate and definitely recommend. Dr. Paul Saladino is an interesting guy too. I like his content. I think he's got a very balanced approach. He even, is quite fair towards carbohydrates, honey and berries in particular, which is good. We need some nuance. We need some other opinions and more research into these things so we can get
yeah,
more of an idea. But yeah, Dr. Paul Saladino is a great source. Of course, Dr. Sean Baker, who's one of the OGs, I guess, of the carnivore diet. He's a great source of information. He seems to have done his research and yeah, he seems to communicate the topic quite well. And it's interesting to see how his own anecdotal experiences have translated into his life.
yeah,
You can clearly see the health benefits and how he's looking as a 53-year-old man. A lot of people like to speculate that he's using testosterone replacement therapy. Personally, I don't think so. I actually think he may actually be hormone free, especially from what I understand of his blood levels, especially in terms of, I think it's SBHG or sex hormone binding globulin, SHBG. Seems to be high, whereas, when people are enhanced or taking testosterone or any other androgen, the SHBG tends to decrease. So that was another thing I found interesting. That also correlates with insulin sensitivity as well. And of course, he would be insulin sensitive because he's not including any carbohydrate in the diet. So why would he be insulin resistant at all? I guess the last channel I would recommend There's an Australian doctor called Dr. Paul Mason, and there's another doctor called Dr. Nadia Ali. Both are great sources of information. They go into the complex details on ketogenesis, the anti-nutrients, and just a bit about physiology and biochemistry in general. So those are some great channels to watch.
Yeah. And I've watched a few of those guys, and really enjoy listening to them and watching some of their
Who do you watch most?
videos. I've watched a lot of Dr. Paul Mason. He's actually in Sydney, not far from where I work. So I've been thinking about going to see him for an old shoulder injury or something. Having a chat about.
Actually, Dr. Pran Yoganathan, he's from Sydney as well. Another doctor I've actually been in touch with. We've been talking a little bit about diet. He's a gastroenterologist, so this is his thing. He understands a lot about the enteric nervous system, and he preaches, I guess, carnivore as well, which is interesting. Coming from a gastroenterologist, someone who understands the stomach. So yeah, his knowledge is quite insightful too. That's another Instagram, or I guess, well, he's not a YouTuber, but if he does ever have a channel, I definitely recommend viewing his content too, because he gives some very, very well articulated information. Yeah.
All right.
There's a few people out there that give some great information. Dr. Georgia Eid is another one. She's a psychiatrist. I guess her videos taught me a lot about the structures of the brain as well. It gave me an idea of it and made me realize, okay, we're on to something here. I think, humans are meant to be eating the animals.
Yeah, cool. All right, mate, I'll let you go. Thanks again so much for giving me an hour or so of your time to talk. And
pleasure. Thank you as well, James.
No, it's much appreciated. I think I struck up a conversation with you on Instagram or Facebook after I think it was Craig Cooper going carnivore, I think it was, and I saw some comments of yours and thought I need to find out more. You sound like you've got a lot of information. So since we first struck up a bit of conversation there, we've been in touch on and off regarding different questions that I had, and you've been fantastic with your time to talk over Messenger and Instagram, and now doing this Zoom conference with me. It's much appreciated, mate.
I much appreciate it to you as well, James. I really appreciate this opportunity, and I'm glad I could share my perspective on this matter with you.
No worries, mate. No, it's been an absolute pleasure. You go off and do spend some time with yourself at the moment, and I'm sure I'll speak to you again over the different mediums in the near future.
Absolutely, sure, sounds good.
All right, thanks, Kaya. Thanks so much, mate.
Thank you.
Cheers.
Have a good night.
See you later, buddy.